The encryption function that takes a plain text and a key to give us a ciphertext, that could be any function at all, as long as there's a corresponding decryption function. It takes the ciphertext and the corresponding key to get the plain text. And by function, I mean a function in the mathematical sense. Given a plain text and a key, the ciphertext is going to be deterministic. It's always going to be the same ciphertext for the same plain text key pattern. You can imagine algorithms that add in some random noise, but if it's not part of the key, then it must be that the decryption side can just filter out that noise without knowing anything, and so that noise doesn't contribute. Without loss of generality, we can consider functions in the mathematical sense. Now, this function could just be the identity function, map plain text directly to the ciphertext, and clearly that's not what we're looking for either. We also want functions that make the ciphertext look random, both in an informal sense, it looks noisy so you can't tell where it came from, but also in the sense that we can't easily detangle that ciphertext and figure out what the plain text was, meaning we can't distinguish between ciphertext that actually means something and ciphertext that really is just noise. Right? That's the goal, and we can make that goal more precise as we go. We also want to have enough different keys to make guessing impractical. Because a strategy for an attacker is always to take the ciphertext and every possible key with the known decryption algorithm and see if they get a good plain text. So we need enough keys to make that impractical. If there were only 3 keys, then an attacker could just try all 3 of them. In fact, since this brute force strategy of trying all the keys is always possible, what we're looking for is an algorithm where that is the only possible attack. If no other attack is practical, and if we have enough keys, then that means we have a secure communication channel.